So for our presentation today, we'll focus on four main parts: traditional construction, then into our unique construction technology, our integrated services, and then the assembly and the construction of the bone structure materials. So before we get in and talk about the bone structure technology, I'd just like to back up here and talk quickly about why people build new homes and how they're typically built. I'm sure in this webinar right now, we have, looks like we have a very good attendance, but I'm sure we have quite a mix of experienced clients that have built homes in the past, maybe builders, engineers. So many people could have many different reasons as to why they're building. And first of all, why do you build? Why do you want to not just buy something existing out there? Why do you want to take the time to build and have that custom process and that custom outcome at the end? Many different things that we hear. And of course, your reasons could differ as well, but maybe it's to be closer to your family. The family could be growing and you need more space, maybe a change of scenery to a new location, which could be getting out of the city or maybe getting in the city. Build a vacation retreat to escape from the busy work week, or possibly a retirement home, maybe to downsize, right size, or even a newer term that people are coining is the age-in-place home. So really meaning that you're designing a home now to stay in forever. And instead of going to a retirement facility or something later on, you could actually bring that help in and be very comfortable in your own home. And then there are also some reasons that we're hearing of here and there, but a lot more since this pandemic has graced us with its presence. And these are more geared towards comfort. I think because a lot of people are spending more time in their homes, we're really starting to see some large factors and things people are finding wrong with the design or the comfort levels of their home. And some of these could be things like air temperature. Maybe it's got such a differential between rooms and isn't consistent. Humidity control. So of course, in the winter, as the air dries out, you're not getting enough humidity in the home when your skin starts to crack and dry out. Air quality is another big one. And then sound transmission is probably a very big one right now with all the home offices and maybe the kids at home and trying to create that nice, quiet place to go and be productive. So into part one here on traditional construction. I won't spend too long on this. Most people, everybody here probably knows lots about traditional construction. It has been around for quite some time, often referred to as traditional framing, conventional framing, or stick framing. And like I said, it has been around for many years and has been slowly changing as the building codes continue to increase every few years with new standards. So as some people here may know, some may not know, in the year 2030 in Canada as a whole, we're actually going to see a pretty substantial increase in the Ontario building codes. And that's going to be pushing towards net zero ready construction. And we'll touch on what that means a little bit later in the presentation. But for the purpose of this slide, it means that conventional stick frame will actually need some major upgrades this time to be able to keep up with what these new standards are going to be. So it could mean moving towards 2x8 exterior walls, some sort of staggered stud configuration. But all in all, it's really going to mean that a lot more material is going to be required, which then in turn in traditional construction means a lot more labor is required. And of course, a lot more lumber required in a home with recent wood prices can have quite a dramatic increase in what the cost is going to turn out to be. Here's an example we like to use, and it could be a little bit far-fetched, but it does make the point that we're trying to make. So two materials here everybody knows, Play-Doh and Lego. Play-Doh we're referring to as the stick frame because it is a set of just materials, pile of materials that are coming to site, and then you're required to measure, cut, and really rely on that execution for that finished project or product and the quality that goes along with it. Versus something like Lego, where every piece is pre-designed and manufactured to have the absolute perfect quality and perfect fit. So it's the perfect size, there's consistency, and every one of these pieces, if you follow the instructions, are going to go in a certain place. There's no cutting, no wasted material, no measuring. So the time really can push you forward that much quicker with something like Lego. And then, of course, you look at we'll look at cost comparison a little bit later on, but for the purpose of this slide, Lego versus Play-Doh, Lego is going to be more money. But if you're taking the labor component into it and you're building the same thing out of Play-Doh and Lego, you're going to have quite a bit more labor involved in Play-Doh trying to figure it all out versus Lego, where you can't really mess it up. It's moving forward in one direction and you shouldn't really be backtracking whatsoever. And here's a little bit more detail about the difference of traditional construction and bone structure. So traditional construction, many times there is just insulation in the walls that meets the Ontario Building Code. And while many only think about the R value in a stick frame construction home, and the builder says, hey, I got a R25 wall. Okay, that's great, but what about, is that a nominal or an effective R value? So the question you want to ask is, what is the effective R value? And the difference of that between nominal is that the effective R value takes in all of the weak points around the building. So every location of a stud, every place that there's a window or door opening and you have a large lintel above with columns beside, there's a lot of structure involved in there, and sometimes very much beefed up because wood is not as strong as steel, that then you're losing on that R value. So you have to take into consideration the overall R value of the building and not just the strongest point in the wall. The other point too on stick frame construction, and this isn't on all homes, some builders are moving away from it, is bad insulation and the quality around it. It is a good material when it's put into the wall initially, but it's not something that is friends with gravity over time. So what happens to bad insulation is it's meant to be fluffy in the wall. It's meant to not be compressed, and gravity actually tends to compress it down over time. So you could be left with a small air gap at the top of the wall with virtually no insulation over 10, 20, even 30 years. Then the other thing about that compression is the moisture content that can get in the wall. So if the wall is not sealed up properly, condensation, well, any air moving is going to have some sort of moisture in it. Drier in the winter, more humid in the summer. But as that air moves through the wall composition there, it is bringing in that moisture. So if it brings in that moisture and hits that bad insulation gets wet, compresses, and that R value almost completely diminishes. So something you're not really going to see until you have to tear down a wall or do a major renovation, tear off that drywall and say, oh, all this insulation really doesn't look so good. Versus something like spray foam that is sprayed in place and holds its form over time. It doesn't change form whatsoever. It is really acting as an air sealant and also providing a very good R value. And then another thing comes down to, and kind of related to the air tightness of the home, is the way that traditional construction is sealed up. So many times it's involving a poly, it's involving rigid insulation, newer system out there, zip panels. But these are great, again, as a whole, as a piece, and in the center of this piece. But once you get to these joints, then you're relying on manual labor, taping, all of these joints up to make sure you're getting that desired air tightness in the home, which is going to translate to energy efficiency. Again, with spray foam, where you spray it and it's a complete seal, you don't have to worry about any on-site labor possibly missing a spot or not doing it properly. And then the other thing, which again isn't on all traditional constructed homes, but it is in many builders, and just the way that the process lends itself to these projects, is really the lack of integrated services. So many times an architect or designer does not necessarily think of all the services that will later be installed. And it's not to their fault. An architect and a designer, and I've been there myself, I used to have my own design and drafting company, and you're really focused on, your scope is designing a house. You're not providing anything at the very end. You're designing that house, and you design it successfully. You pass that along to the builder who works with the client. They build the house. They take it over from there. So where an architect is going to be more involved with somebody like an architectural designer, for sure. But then you get into something like integrated services, thinking about your HVAC, your electrical, your mechanicals, all ahead of time with computer modeling, 3D modeling, really see if there's any clash detection there. And we can figure all this out ahead of time to make sure that you're getting what you're expecting and what you're investing in. On next to our next part here about the construction technology of bone structure. So bone structure is made up of many pre-designed parts that all have a specific place in our homes. Many of these parts have been developed by bone structure and many of them are patented. The structural steel parts are made up of 11 gauge galvanized steel in which 89%, up to 89% of the steel comes from recycled material. So sometimes people think of steel versus wood and the carbon footprint behind it and things to go along with that. And they don't think that, hey, a steel home, sure, it may have a higher carbon footprint up front, but it's actually a recycled material. As much as you just are assembling a bone structure home, you could actually, in 100, 200 years, whenever you want to take this down, you could actually dismantle this home and recycle all of the components, which can then be reused. So while all of the superstructure is made up of steel, we do still have some wood within the structure. The subfloor is one of them, which is made up by 5x5 pre-cut and pre-pierced birch ply sheets. So a very high quality plywood. And again, the pre-pierced means that all of the holes needed around the perimeter of that plywood or through the center to fall into the joist are already cut, and they're going to line up exactly with the floor joist below. So no figuring out how to cut it, where you're going to put these pieces that they're going to line up on joists. Take a piece, figure out where it goes, put it down on the floor joist, zip it into place, and you're done. And then another area we use wood is on the top of our structures, on our roof, which is something called a structurally insulated panel. So kind of like an ice cream sandwich where the cookie portion is the wood, and then the great part on the inside is the great part of a structurally insulated panel. That's all the insulation. And just a very thick, full thermal break of insulation. So you're not going to have any thermal bridging happening between that and the roof structure. And then while all these parts are all pre-designed, the use of them, of course, can be in many different ways, resulting in many shapes and many different styles of homes. And then what are some of the benefits of a bone structure home? So as you would probably assume, steel does have quite a bit stronger of load-bearing capacity. So we can have larger spans, typically with less of a need for interior load-bearing partitions. It's a great system for island builds or any location that is a little bit more remote, or say down a long winding road up in the Muskokas, Parry Sound. You get into a lot of these properties. And it's really a great system because you're bringing all of this material to the site and you're not bringing anything back. You're going to have an empty truck coming back and zero garbage bins needed for the entire assembly of the bone structure portion of the home. You will need a garbage bin a little bit later for flooring and some of those materials, but really in the shell construction, you are losing a lot of that potential waste, which is what you paid for. It's going into a garbage bin and being sent back to the dump. So every piece and material is used that we send out to the site. And again, this truck is going to come back absolutely empty. Since the entire structure is made up of steel, it will never be affected by water and galvanized steel. Therefore, you'll never have any mold issues on any of the structural components. So, and then we also use a closed cell spray foam that we spec on all of our projects. And that means that none of that moisture can travel through that spray foam and get into that structure and then ultimately into the wall, creating any mold spores or any deterioration. And then, of course, not so much here, but termites, carpenter ants. Carpenter ants there are quite a few of here. And they're not going to be eating away at your structure because it's all steel and they're not going to find that tastes very good. Superior resistance to earthquakes, floods, fires, and more importantly for us, heavy snow loads. Just with the structural integrity of the system, the way that it's all pre-engineered and designed, you see some cross bracing in this picture, those big X's between the walls. It's very, very structurally sound that you don't have to worry about being on Lake Huron, facing the water, get the prevailing winds attacking the waterfront facade wall and having to worry about any shaking or rumbling going on. That won't happen at all in a bone structure home. The assembly is very quick and efficient. A general rule of thumb is typically that a builder can install about 1,000 to 1,500 square feet of bone structure, or sorry, 1,000 square feet of bone structure in about a week and a half. So quite rapid, but also to more of a consistent timeline. Where stick frame construction, you have so many trades involved in that exterior wall assembly. With a bone structure home, all of the parts are there. There's no running back and forth to a Lowe's or a Home Depot, a big box store. Everything's there, everything's needed. So it's just really, okay, when are we starting? When are we finishing? That's it. Just assemble, put all the pieces together. And then too, another big thing is just the integration again of the trades. So very easy mechanical and plumbing installations. So one thing is we look at like the mechanical design ahead of time in the 3D design stages to make sure that the HVAC design is going to fit through all of our pre-cut holes in our joists, which are pretty hard to see, but we have a little better picture in a little bit later in the presentation. But if that isn't done or something needs to happen on site or be changed, very easy to do so. And you don't have to rely on any bulkheads to make this happen. You can really get that. Again, the expectations that you're having at the beginning are more likely going to be met because of these integration of trades. And this thought process came from our founder and CEO, who came from the aerospace industry. He worked with Bombardier for quite a few years and brought with him that ideology of creating the floor joist like a airplane fuselage. So thinking about, hey, when I'm in the airplane, all of this wiring and everything in the mechanical is coming from the front to the back of the plane. Where's all that located? Nobody sees it. There's no bulkheads. It's up in the round part of the ceiling up there and in the floor, and all figured out all the sizes of everything to make sure that it's going to fit. Because of course, later on in an airplane, you're not going to throw a bulkhead down the center where people are bumping their heads into. So the same idea of the home is that we don't want to give you an unsightly bulkhead later on down the road. We want to figure out if that would be needed. Okay, why can't we run this through these massive holes that we have in our floor joists? And then get on to net zero, the term net zero and what this means. So there have been quite a few terms over the years. I got a couple of them listed on the side here. R2000, Energy Star, Passive House. So what are these terms and what do they mean? Well, R2000 has been around for quite some time, even back in the 90s, and then in early 2000s, they tried to increase it. But an R2000 home would typically have about a 10% increase over the Ontario Building Code standards. Then you have Energy Star, which is a little bit better, and it would have an increase of about 20% over the Ontario Building Code. Then R2000 came back and said, okay, we want to be even better. So they released new standards in 2012, which would have an increase of about 45% in your home's performance. And then we have Net Zero Ready, which is an increase of about 70% of your building's performance. So all of those maintenance costs of your heating, your cooling loads are all going to be decreased substantially and not be as required because that building envelope is so sealed and so energy efficient. So then the difference between net zero ready and net zero energy. Where net zero ready, this is what bone structure is providing, is the net zero ready building envelope, which means you're going to have very low operating costs for sure. And then you only really need to add an installation of some sort of power generation to become net zero energy. So that just means the net zero energy now means, great, the building envelope is great, but now we have something to capture the sun or the wind, most commonly the sun, with solar panels. So we can then offset the costs of our consumption. So typically net zero energy means you have your consumption, you have your production. Those are going to offset each other and leave you with no bills in the end. So that is the way of the future. But even for 2030, they're first going towards net zero ready. Say, guys, everybody, all new buildings are going to be built very energy efficient shells. Then we'll worry about in certain places where we can get to net zero energy. Hey, we'll give you guys some incentives to do this later on. So you don't need to be net zero energy at the time of building. You don't have to have the solar panels installed or anything. It's just as simple as running a conduit up from your electrical panel to where the solar panels would be, and you can easily install them anytime in the future. but you do have the peace of mind knowing that you're already going to have a very energy efficient building envelope. So we've already seen this change happen in California. Like I said, we have an office in San Francisco, and it was actually 2020, January 1st, that they started the net zero ready construction. So we've been doing great over there just because of the demand for net zero ready building systems. And then British Columbia too has really been setting the pace for Canada as a whole, because they introduced something called a step code, which is trying to get people a little bit more slowly to meet that 2030 goal. Instead of, say, in 2029, people are building typical Ontario Building Code homes, then in 2030, hey, net zero ready. It's pretty drastic change there. So British Columbia said, hey, let's kind of step our way into this and ease out some of these builders' involvement in it and the challenges that they may overcome or have to overcome. And it really is like, why build an energy efficient house and so energy efficient? Our 2000 Energy Star, net zero ready. And it's really because you want to ask yourself the question, how long am I going to be in this home? If you're thinking, and we're already 2021 now, 4 months into it, if you're thinking you're going to be in the next 9 years still in this home, well, when you go to sell it in 2030, 2035, 2040, you don't want to then be competing against these brand new net zero ready building envelopes, which are going to be marketed as such. You're going to have a typical Ontario Building Code home that's going to sell for less than a net zero ready home. So that is one benefit. And then the other benefit, of course, is just reaping all the benefits of the lower operating costs up until that stage. Now into more specifically the insulation and air tightness. Many years back, while I was studying architectural technology, my building science professor said to the class, and this is another far-fetched statement, even more so than the Lego versus Play-Doh comparison, but it's always stuck with me because the point that he was trying to make really made that point, and it's stuck in my head since. So he said, if you want to keep warm in the winter, would you chop up a sweater and eat it and put it on the inside? Or would you wear that sweater on the outside to have that full thermal break around your body? And we know the answer to this. But again, it does get that point across that you should be installing the bulk of your home's insulation on the outside of the structure, not in between the studs like we see in wood frame construction. So a big mentality shift needs to happen, and it is already happening. And there are some technologies out there for stick frame construction that are helping it get to these next stages, but bone structure is already there. We're already doing this, and we're already thinking, hey, the majority of this insulation needs to be on the outside of the structure where it's not going to be interfered with any studs or structural members that are just decreasing that effective R value. As for the air tightness, as some would know who have experienced building a home, there are different methods to go about applying for a building permit. One of them is a prescriptive method where you follow the Ontario Building Code standards, and the other is a performance method, where the key on this performance method is building modeling itself. So modeling the home inside a computer and putting in like the heating and mechanical systems to then generate a hypothetical performance level of it. And then part two of that is a blower door test on the home. So once the home is at an airtight stage, windows and doors are in, then they actually take off the front door, replace that with a blower door fan. And what this blower door fan is going to do is depressurize the home. So it's going to try and draw in air in all of the weak points around the home to see, hey, how airtight is this home? And then oftentimes you may have seen it in some videos online. You'll hold smoke up around the windows and doors, and you'll see that the wind is actually pulling this smoke inside the building. So that tells you, okay, there's some air leakage. We need to fix this prior to getting too far in the construction. So with the standard details of a bone structure home and the way it's assembled, we're already going to guarantee that you're going to have great blower door testing results. And we do mandatory blower door tests on our homes just to say, again, we want to make sure your expectations from what we tell you at the beginning are still going to be standing at the end of your project, and you're going to be happy with this result, knowing that you have a high performance home. It seems we've had quite a few people join since we started. So just quickly to mention that if anybody here has any questions, even those that are already here, just a reminder to throw them in the Q&A section and we can answer them throughout the presentation, or alternatively, we can answer them at the end in a live Q&A session. So here are just a few homes, net zero homes that we've done around Canada, just to show a couple pictures. Here's one, of course, that is facing due south. So you can see the solar panels tilted up just a little bit to get that optimal surface area being perpendicular to the sun's direction. This home was built in, as you can see there, Vancouver, BC. Here's an off-the-grid home in Mulmer, Ontario. So what off-the-grid is, as the name sounds, it's not connected to the electricity grid. So it's a net zero energy home that is totally self-sustainable. So all of the production, the solar panels, what they're grabbing right there from the sun, all that energy is then stored in batteries, which is then pulled out of the batteries on cloudy days or throughout the winter when you don't see the sun for a couple of days or a couple of weeks. So then you can totally be off the grid and not have to worry about not having any power and not having any bills to pay. Here's just an interior shot of that Mulmer home. Professor Mark Jacobson's house here. So he actually had a net positive home. Mark Jacobson is the professor of civil and environmental engineering at Stanford University and the director of Stanford's atmosphere and energy program. So Professor Mark Jacobson actually reached out to Bone Structure, loved the technology and the idea, and said, hey, I want to be the first home in California in bone structure. So that was a few years ago now, but we are keeping in touch with him, and he's still actually receiving checks back from the hydro company because his home is producing even more energy than it is consuming. And now I'm just going to pass you off to Kim, who's going to talk to you for part 3 here about our integrated services.
Hello, everyone. Thank you, Jason. Thanks for joining us this evening. I'd like to talk to you a bit about our services and how they're integrated throughout our design and build process. I'm sure you all have a very, very good dream or a pretty good idea of what your new home or cottage is going to look like. I know I did, as Jason mentioned, I built my own home a couple years back. We decided to GC the project ourselves as we had already done a few.
So yeah, unfortunately, we won't get to hear any more about Kim's dream right now, but maybe when she comes back, she can share a little bit more details on that. Because again, it's just great that she's been through the process and she can really relate to everybody, what they're going through and really how to make that an enjoyable process. So not getting into too much detail on this slide, but really what you need to know about this slide, why we're showing it right now, a lot of different steps here. But what you want to know is that we take everything in stages. So we're not going to jump forward at all, right, to construction drawings, design development. We want to work on the conceptual design, talk about your site planning, the 3D massing, the spatial planning on the interior, walk around the space in 3D, talk about even some color schemes, some interior potential kitchen layouts from L's to galley kitchens, and then really to look at a good idea of costing in this stage to make sure, again, we're not getting ahead of ourselves and that we're staying in line with your expectations and with your budget. Then from there, we're going to get into more detailed drawings, and the drawings just get more and more detailed as we move through the process. So schematic design, design development, and then construction, engineering, and our technical drawings, which are needed for the permit application. So first is that conceptual design. So on this, we kind of have option 1 or 2. Option 1 with the custom design being the most common option with bone structure. But we also do have some collections and inspirational plans on our website that people can choose from. And it's whether you want to choose the plan in its entirety or take ideas from that plan and merge them with your own ideas or some other plans. For instance, we've had clients that say, hey, the master bedroom layout on this plan is perfect. It's got my ensuite where I want it, walk-in closet. Maybe I go through my walk-in to get to my ensuite, but I don't like the rest of the house. I just want to take that and plug it in over here. And we can absolutely do that. And then on the flip side, back to the custom design, we can start off with just that pipe dream. What is the dream? How many bedrooms do you want? How many floors do you want it on? Do you want a basement or not? Which could be a walkout, could be just fully embedded in the ground. All that criteria. And then our in-house designers could take that and run with it and develop a unique custom plan for you. So, and with the design, we do have a team of not interior designers, an in-house team of architectural designers, sorry. But sometimes we do also have projects that come to us that have already been designed by an outside architect, and that's okay too. So in this case, we still have to get involved, but in the conceptual phase, we'll stand back a little bit and just make sure the bone structure system is seamlessly incorporated into the design and how that's going to work with that conceptual design. So as part of the conceptual design process, we will do a bylaw study. So this means that we're going to conduct the research to find out any specific requirements for your lot based on your location and your municipality. So side yard setbacks, maximum building height, the front and rear yard setbacks, what the lot coverage is, if you can have any accessory buildings like a bunkie or a boathouse, what the restrictions are on those. And then, of course, there's some other bylaws as well. But just to make sure that once we grab your ideas, we grab what we can do, so what you want, what can be done, merge that together to try and fit within that budget. And that's all something we want to align ourselves with. And then another thing too, which you can kind of see here, it's a little confusing, but what this yellow line is showing is the path of the sun. So we like to do this on all of our projects, which is called a solar study. So a lot of people think, hey, well, I'm facing south. That's my waterfront view, which is great. I'm going to get sun on my beach all day. But at the same time, if you really open up that south facade wall with a lot of glazing that isn't tinted or anything, when that sun drops down in the winter, even in the summertime at that higher level, it could be beating so much into your home that you don't want that much heat inside because your cooling load isn't going to be too high. So we want to make sure that we're designing smart. We want that view, but we don't want too much sun coming in. On the other hand, when that sun drops down in the winter to a lower level, we want that sun to come in that wall on the south side and accept that free heat, because then it's going to offset your heat load in the winter. So there's a few things on this, and it's called passive design. It's just to make sure we're taking that sun and those prevailing winds into consideration to make sure that later on you're going to have the least amount of loads as possible for heating and cooling. And then once we complete all this analysis and combine it with your ideas, then we'd be ready to present you with initial concept presentation, which we can make any necessary changes together to complete this custom design. So a lot of back and forth from there happens after that first concept, really to tweak it. Because again, we don't want to go too far until we're all aligned, your expectations are met, and of course the budget's met as well. And then we can move forward into the more technical drawings. For the initial concept presentation, which typically happens via Zoom, especially now with this pandemic, and most people I think are finding it okay right now because it's kind of the next best thing to meeting in person. But we pull up the screen, and we have our designer, project manager, and the sales rep on the call. And we're going to first focus on the volumes and the overall design. So how many bedrooms, how many floors, that type of thing. We want to make sure we're headed in the right direction, again, before getting too detailed, and to make sure you're liking what you look so far in terms of the architectural design. And then after the concept is completed, we will then continue to work and create more and more detailed plans up until the point that we are actually building the entire structure virtually within our 3D programs. So although we do not entirely focus on the structure at the initial stages, all of our designers, engineers, and BIM technologists work in the same office and frequently discuss the feasibility in terms of meshing architecture and structural engineering. So if anybody's ever seen that, the Timber Kings, Pioneer Log Homes, where they actually assemble all of their parts, but then build them in the factory or out in a yard to make sure that they're all fit, then they disassemble it and bring it all to the job site. So while that is absolutely great that they do it to make sure it's a good fit and that the on-site construction time is going to be kept to a minimum, at the same time, that's very, very costly. So it's much preferred to do it inside the computer, and where things are exact, they're going to fit. We're dealing with steel, so what's shown on the computer is going to be the exact same thing that's pumped out of manufacturing, and down to every little bolt of the system. So to make sure everything's going to fit together properly. Because it really does, it happens too often in the industry that with stick frame construction, that an architect designs something which the client falls in love with, hand it off to a structural engineer. The structural engineer wanting to change something, add a beam here or there that the architect didn't think of. And I've dealt with this firsthand. I used to do structural detailing at a structural engineering office that we got the plans from the architect, and we had to incorporate our structure in there. So then we go back to the architects and say, hey, you need a beam right here to hold that wall that's just floating in midair. And then the clients say, well, I don't want a beam there. I don't want any columns. And you have that kind of lack of integration within the process, where at Bone, we have all these services in-house. And normally in a pre or post-pandemic world, they're all sitting within the same office, and you could throw something to the next person. That's how close they are. So that coordination is really key in our design to make sure that, again, just aligning your expectations and making sure you're getting what you're investing in. Here's an example of a structural model of the shell of one of our homes. So it's color coordinated by part number, can be zoomed in 3D down to the smallest part. This has been pretty crucial for builders, especially builders that have never built a bone structure home before. And that is quite common, where a client already has a relationship with the builder and wants to bring them in to build the home. And that's fine, because with a program like this and all of these parts that are color coordinated, they're all labeled as well by that part number. And with the program, you can actually type in the part number, and then it's going to zoom you in into where that part is required exactly. So there's no guesswork, and it's really going to speed up and make them more efficient, even though they haven't found those efficiencies yet because they've never built a home before. And then here, just nothing exciting here. This is more of the permit and the architectural and engineering drawings that are needed for the permit application. And then here, just to highlight the scope division between bone structure and the builder. So what bone structure takes care of is the architectural design, the technical and engineering drawings, the permit application, the supply delivery of the bone structure materials, and the supply and delivery of the exterior doors and windows. So we are not involved in the on-site construction, but we can introduce you to a builder that likely introduce you to a builder. It does depend what area you're in, that you can work with to do all of the on-site construction. So the builder's going to jump in after that permit application is approved and we get the permit back. They're going to start then excavation and foundation on site, which yes, could entail also doing tree removal, demolition, and any of that work to prepare for the excavation. Then they're going to wait for once that foundation's done. Typically we get into production after the permit, and the materials of the bone structure building envelope are going to arrive typically around when that foundation's complete, maybe a week after, if all goes well or perfect on the job site. And then the builder is going to assemble all of the bone structure materials. And that's where Mike McCoy, our construction manager, comes in. And he's going to assist at a higher level to really ensure that the quality control is there, that all the pieces are where they're supposed to be, to eventually have that sign off to go back to our structural engineer to say, this home has been built according to bone structure's high level of standards. They can now proceed on to the next stages of the build, which then are all really conventional. So installing the spray foam, the windows and doors, installing exterior finishes, and then they'll also take care of electrical, plumbing, and HVAC, and the interior finishes. Quickly here, I think we're somewhat running out of time, so I'll try and run through this quickly, but the assembly and construction of bone structure materials. So like I mentioned, once the on-site construction happens with your builder, at the same time, we're going to be producing all of the materials in the manufacturing facility to line up quite well that the materials are going to be sent out once that foundation is complete. So what's good about this method and kind of this process that we have is that the builder can focus on what they need to focus on. They don't have to worry about scheduling the parts of the entire building envelope when they're going to get to the job site. They just let us know, hey, I'm going to have the foundation ready at this time. Get the materials here at that time. And then we'll coordinate. I think we typically have about 5 or 6 different deliveries that we're going to coordinate at the times that they need them. So it's more of the ready to install shipping, instead of shipping things out, just dumping everything on site, and then they're not going to need half the things till 3 months down the line. A common question we're asked is what type of foundations are possible with a bone structure? The answer is absolutely anything you like. This home was built in LA. It was actually featured in the LA Times. It's called the Bridge House. If you're curious on more pictures, we can definitely send you some. But it has everything. It was about 220 feet long, has a slab on grade, crawl space, a bridge, which isn't that common, but we can do, and then a full basement foundation. So absolutely anything is possible with a bone structure home. Here's a picture just showing the flat stacking method of delivery. So really trying to make it the most efficient delivery possible, thinking about that carbon footprint as well. If we can flat stack everything, fit more on one truck, while the transportation of point A to point B is really reduced in the amount of trips back and forth. Just a assembly plan here. So showing what a builder would see in addition to the 3D program that we give them access to, just showing where some of these parts go. We don't have to get into detail on this because I don't think we'll be installing the bone structure homes, but very, very simple to read. Just that this part goes there, this part goes there, and work your way around the perimeter, and there you go. You got all the walls up. So one thing you don't see in this picture is that waste bin, because a waste bin is not needed when installing the bone structure shell materials. A picture here showing the really the completed portion of the bone structure offering. So once that foundation's in, everything above that foundation, so all these steel posts, the cross bracing in here, the roof structure, these little accessory steel pieces on the outside, these rigid insulation panels, the SIP panels on the roof, which looks like wood, but that's actually just filled with foam. That is all supplied by bone structure and then installed by the builder. And then this is the same picture, but with the spray foam now applied on site by the builder and the windows and doors installed. Again, the easy integration with trades. So a little bit better picture here of that airplane fuselage idea with the massive holes cut out, ready to accept all of the mechanical, electrical, and plumbing. Quickly here, just a couple pictures of interior and exterior finishing. The reason is just to show you that anything is possible with a bone structure home on both the outside and the inside, from metal composite panels to wood siding to composite wood looking material, stucco, brick, stone, anything you can think of, we can do it on the exterior. And then the interior as well. You got wood ceilings up here, probably pine, tongue and groove. We get drywall on the inside. You could do wood on the inside. Again, whatever your heart desires, we can achieve. This is a view of the same home here, which is in Whistler, BC. Again, just to show some different outside materials. The same home, but the kitchen area. Another view of the same house. I'm sure many of us would like to have this as an in-home office to be working away during this pandemic. Open the windows, get the nice fresh air. This home built in Saskatoon, Saskatchewan, again, showing a different use of materials and also a clever idea for the garage. So you get onto a tight lot and it's, again, thinking custom design, site-specific design. How do we really maximize what the clients are looking for? So they wanted a 2-car garage, but you can see that if this was put up on the main floor, you're really taking away a lot from that main floor living space. So why not throw that down in the basement, have a very good, well-working drain here to accept all that water and flush it out back to the street. But then they can throw the garage in the basement and not lose anything from their top 2 floors. Here's a home built in the Laurentians with a monoslope roof up here and a flat roof over here. Because the question is, and just going on to this slide, in Vancouver, can we do other designs than typical flat roof style homes that you see all over our website? And the answer is yes, we can do different styles. We get into certain things that we can and can't do. We don't have to talk about that right now, but if you do have an idea and you're not sure because you've looked at the Bone Structure website and you saw only flat roof style homes, please reach out to us and we can let you know right off the bat if yes, we can do that, or no, you'd have to make some tweaks, and what would those tweaks need to be in order to make it work with Bone Structure. An interior picture of a home in West Vancouver. Here's that bridge house in LA. The idea on this house was really to merge the inside and the outside space. So a lot of times in homes that we have in Collingwood, Muskoka areas, we have a lot of these massive sliding doors as well, really to connect that inside and outside, right? And almost confuse the mind where you are to bring that nature inside the home. Another common question is, where are Bone Structure homes located across North America? So I mentioned we have an office in Quebec, Laval, Quebec. We have an office in San Francisco, and then we have a location here in Ontario. We don't have a physical office here, but we have our presence here in Ontario. And just to zoom in a little bit more, this is probably a couple years old now, but majority of our projects are kind of in GTA, Blue Mountain, Collingwood area, and then up towards the Muskokas, Haliburton, Kawartha Lakes area, with the odd few up north. We got another one coming up in Sault Ste. Marie, and our farthest to date will be one actually up in Kenora, Ontario. So we do go all over the place, but in some of these other areas outside of kind of our core areas of Blue Mountain, Muskoka, and the GTA, we may not have a builder to introduce you to. It doesn't mean you can't do a Bone Structure home. It just means that we're going to have to train them up a little bit and utilize our construction manager a little bit more to get them up to speed. But it's not rocket science. The whole system is designed to really be a simple installation and assembly, again, to give you what you're investing in. Next steps, and where do we go from here? So first, we want to have a conversation with you. So if anybody joined late and missed the couple first slides, first off, you'll talk to Jose. So Jose is just going to filter through, and because we don't have a product that is going to work for the masses, it is a specific product. Some people it may not work for with roof lines, with budget. We want to find out about your specifics, your criteria of what you're looking for. We want to see if there's a good fit there. We have an offering that is set. You have a set idea. So let's talk and see if we're aligning our expectations. From there, then we're going to get into more detailed conversations. So Jose is going to pass you along to either Kim or myself, and we're going to want to talk more about the specifics. So now, okay, well, let's look at this in more detail. Let's figure out what some of these room sizes are going to be, not into the detail of, hey, my washroom is going to have this vanity here and the toilet here and this and that. We don't have to get into that yet. Our designers are the masters of that, so we'll lean on them for it. But the overall high-level sense of, are we talking in the same thing, in the same language? 3,000 square foot home, that can cost many different things. So based on your criteria, 2-story, 1,500 on 2 floors, I want a garage, a porch off the back, then we can really give you a good sense of feasibility or not. What could this thing cost? We will let you know, and then from there we can continue on the conversations or not. In the meantime, if you're not ready to reach out, or even if you want to reach out and just to do some of this in parallel, some preparation is definitely key to the project. You don't have to figure out everything right now. Don't worry about that. You're going to overwhelm yourself. Just really about the initial things. So what is this, the allocation of space? Is it a 2-story home? Is it a bungalow? So what is the scope going to be? Do you want just a closed-in shell, or are you looking for a full finished home from a builder, turnkey, which does mean, just as it says, get handed the keys, turn it, bring your furniture and your clothes, and you're moving in. What are some of the services required? So do you already have a survey on the property? Your general design wish list. So again, not thinking into the specifics yet, but a general wish list. Then an overall budget. We'll talk about budget quickly on the next slide here, which could end up being a couple of questions at the end. And then also to the timeline. When are you thinking? The building industry really has been very strong over this pandemic and even prior to the pandemic. So timelines are not probably as quick as many think that they're going to be, and especially to lining up a builder. So us being the design engineer and supplying the building envelope materials, we can work that into a schedule, a realistic schedule. There's going to be some set times in there with permit applications or engineering time, but then too, lining up a builder. If a builder is available tomorrow, you probably don't want to use them. So the builders that are booked up in, say, the springtime or the summer of this year is great. That means they're busy, they have a good reputation. And then when are they going to be available for your project? So we're going to want to figure that out as well, and then work that into the timeline, make sure it meets your expectations, and then do a work back schedule from there to say, we need to be out of design by this time, out of engineering by this time, you have to have your permit by this time, and then we're going to be set off to really meet that timeline. And we will work with you together on this, and our project managers are that master of that schedule, so they can really keep us on track. And then here, a slide that I love going over because it's the common question in the industry. My past place of employment, I worked many trade shows, and the common question going around the booths is, what's the price per square foot? Well, price per square foot is difficult because you don't go into a car dealership and say, hey, what's the price per square foot of this car? Or you don't walk into a grocery store and say, what is the price per bag of groceries? Well, what do you want in that bag of groceries? Do you want potatoes that are super heavy, so it's going to maybe cost more per weight? Or you're going to have bread? Which one? Or sirloin steaks? All different factors that, like custom building, even more so in custom building, there are thousands of things to change price that are factors on getting to that price. So we don't want your price per square foot, what you're trying to get to. We want to know what you have to invest in dollars, and we're going to try and help you work towards that. So being the designers and the engineers and not the builder actually works in our favor because we're working with you. We're going to work on that design, grab your wish list, and incorporate everything we can in there. Then we're going to work with you to go out to the builders and say, hey, what are your fees for our client to build this home? And we can go to a couple if we need to, but we're going to work with you on that to really try and maximize this investment and get what you're looking for. But a couple good examples here on why price per square foot doesn't work. The finishes can drastically change price per square foot. $50,000 kitchen versus $20,000 kitchen. You didn't add in necessarily any more space to that kitchen. You just went with a higher end kitchen. So $30,000 delta on the same size home is going to increase your price per square foot. Are you getting ripped off? No, you're getting different value in the dollar that you're investing. Fenestration. So windows and doors are quite expensive. They are a key part of the design of the home. And especially too, when you have a view to look at, you want to invest a good amount there, but they do have a dollar value that is attached to them, and they don't add any space in the home. They just add cost. So again, price per square foot is going to go up, but it's just then deceiving you in what you're getting. Any accessories, so that's referring to any like covered porches or screen porches that don't add to the square foot part of that price per square foot calculation, but they add to the price part. So again, just deceiving. Mechanical systems. And another one too that's just mentioned on the right here with this picture is ceiling heights. So price per square foot is a two-dimensional metric, square footage, where we're building three-dimensional volumes, cubic feet. So 8.5 foot ceilings versus 14.5 foot ceilings. Again, you have more cost in 14-foot ceilings. You're not adding any more space. So your cost is going to be higher, but you're not adding any more square footage. So again, you're going to have a skewed price per square foot. That's where the whole idea of price per square foot will leave aside. What are you going to invest in? How much? You have 800,000? Do you have 1.5 million? And then what do you want? And then we're going to align that with you and get you exactly what you're looking for, and hopefully more than what you're looking for, and really try and maximize that investment. So just to end off here, typically we love to hold these presentations live. We did so before. If any of you have been following us for quite some time, we used to hold info sessions, open houses, bare bone events, which we call them, is just the shell structure installed, and we invite you out. We love those because at this point, we can now stop the presentation, come out and meet you guys, put a face to the name, answer some initial questions, get to know you a little bit, and see if there's a good fit that way. So since we can't do that for the obvious reasons right now, please know that Jose, Kimberly, and myself are all available at any time. So we want to have that initial discussion. And again, to help determine if bone structure is going to be a good fit for your project.